In this video, I will describe some changes that I've made to the GDB regview package. The original GDB regview is not my own. It was originally developed by Fergus Noble. Many thanks to him for that work. But I found that there were some features that I needed that were not there, and I found that it was actually rather easy to add them. So what are those features? Here we are in a GDB session. As it was before, you could show a single register, but I found it that I often wanted to see more than one register. So I've added the features for globbing. Note here that I have a percent and a star, and with this one we can see multiple registers at once. Taking it further, I also found that I wanted to be able to compare between a previous state and a new state. In particular, I had some code that I was trying to get to work in ChibiOS RTOS system, but some of the register settings I couldn't quite figure out. But I did have a functioning prototype that I had developed using the STM32CubeMX, which did give me the settings, and then I needed to compare what the difference was. So the way that this works is in your from GDB, you run the command regview save snapshot followed by a file name. Then you quit, go to your other GDB. I'll just restart again. Then in my to GDB, I run the command regview load snapshot with the same file, followed by running regview diffs. So this gives me the differences between register settings in the from and the to view. But which registers is it looking at? Regview is based off of the register definitions as defined in this page here. GDB regview itself comes with a copy of some common of these files. In my particular case, I'm running on the blue pill STM32F103C8T6, something like that. But there are a bunch of others, including non-STM parts. Last, I will talk a little bit about how the GDB regview feature works, because I found that adding Python capabilities to GDB is actually fairly easy, and so perhaps in a way to encourage you to try doing it yourself, I'll walk through the code a little bit. So here is the main GDB regview file. You have to import some stuff, in particular import GDB. This of course is running inside of GDB. So you first need to have a base command. Since the regview command is a multi-level type of command, you can do regview and then do tab here to get a number of sub-features, diffs, loads, load snapshot, and so on. So first you need to define the base level command. So here, just regview. Then I define a subcommand, regview space load. I forget what command support here means, but the second option here is useful in that you can tell it, okay, here actually I'm asking for a file name, and so then it will know how to do tab completion because of this line here when running the command. So for example, I do here load, t, h, and then tab, and boom, we have file completion. Invoke is the method that is run when you actually invoke the command. The same thing here happens with regview show, regview snapshot, save snapshot, and so on. Finally, you have to then actually instantiate each of these commands. And so this part so far is easy, but the code for generating the functionality itself is also pretty easy. So let's go into that. As an example, let's talk about the regview show command. I have this RV object that I'll talk about here in a minute. From which I will ask it for a list of elements, of register elements. So this is basically an interpretation of the register definitions that I mentioned from here. And it takes that list and prints out, takes that list and prints out the information for each. But where does that information come from? Well, that goes down into this register pi. So here I have a register object. Again, this is still just the XML from the website. I ask it for the address, which is just a address number. Here is where the magic is within GDB. I ask GDB for its first inferior. Since this is a embedded thing and my embedded thing has only one core and only one thread, there's only going to be one inferior. I don't know that you'll have a longer list with embedded, but when running GDB in regular Linux, you may have multiple of these threads. So then here I tell it read memory from this address, and I want 4 bytes, and then I unpack them, and then I can go ahead and manipulate those bits. This code is not mine. Well, it's perhaps a little bit rearranged, but this code is from the original regview. But there's much more that you can do with the GDB Python interface. The documentation for it on the GDB website is actually pretty good. And I found that I've managed to do some interesting things with that as well. Previously, before I discovered regview, I had already written my own variant on being able to show register settings. So in particular, if I print, so here I can print the RCC register. So for example, I had written a pretty printer for showing the RCC registers within TM32 family, which generally it gives you a bunch of registers, but it doesn't give you the interpretations of what they mean. So I had done this, well, if you have the CR register, it's got a PLL ready in it, and it tells you what these things actually translate to, so on and so forth. I've also considered adding a small little GUI, having it pop up a little WX window that will show you here's all the clock registers, here's the ADC registers, here's the DMA registers, and so on. Haven't gotten to that part, but perhaps I will. One thing that is lacking in the regview is that it doesn't give you much in the way of interpretation. So for example, if your GPIO A block does not have its clock enabled, it could be helpful if the GDB view were to show you that, hey, that's, even though you have the other settings, the clock to it is not enabled, so therefore you're not going to get any behavior out of it that you would want. Also, another thing that I didn't like about the pretty printers that at least I put together is I wasn't able to find a way to add new lines. So all this stuff here is kind of run on. In any case, that's regview within GDB. I found it to be very helpful to help me figure out what I was doing wrong. Perhaps it will help you as well.